Rana, and I'm a computer science major here at NJIT. Um, as for, I'm also a sophomore, and as for career interest, I think I'm interested in becoming a software engineer, hopefully someday a project manager, and I think I'm interested in some type of system level development or even operating system development. I really enjoy learning more about virtual memory and all of its applications and just how the system works, the software works deeper inside like the inner workings of everything. I really enjoy the lower level stuff, including assembly language, and even learning about pipelining was very interesting. So maybe some application with software engineering to like system level. But anyways, we're going to talk about Intel Optane and virtual memory here today. Just an overview of what we're going to go over today. What is virtual memory? Replacement policies, Intel Optane, what does it do? And the future with Intel Optane. What is virtual memory? It's a storage allocation scheme in which secondary memory is addressed as though it is a part of main memory. It takes advantage of the memory hierarchy to produce faster secondary memory access with relatively low cost, having economic benefits as well. So that means cheaper parts. Virtual address versus physical address. A virtual address is generated by the CPU during execution, and it's used mainly for virtual memory. On the other hand, physical address is the actual location in secondary memory. Logical addresses are converted to physical through hardware, allowing a program to access data in secondary memory. The memory management unit. This is the piece of hardware that does the conversion from a logical address to a physical address, as mentioned before. Essentially, it also handles all memory and caching operations associated with the processor, and it's usually integrated into the processor. Some key terms. Pages are fixed-length blocks of data in secondary memory. Page tables. Page tables consist of page table entries which hold the physical addresses to access pages in memory. It's used in conjunction with the memory management unit to map virtual to physical address. Page faults occur when a program asks for data not found in main memory or on the page table. Thrashing. Thrashing is basically the OS wants to keep swapping data back and forth from main memory, RAM, and secondary memory, the hard disk, because there are page faults / page table is full. And it should be executing instructions, but instead it's focused on swapping back and forth, so it slows down the computer. Virtual memory tries to minimize this by choosing the best replacement policy, which we'll discuss later. And demand paging only brings pages into main memory when the reference is made to the location on the page. Pre-paging. Pages other than the one demanded by a page fault are brought in, and it's usually chosen by the pages nearby the one demanded, so spatial locality. So here's some replacement policies. Optimal policy selects the page for which the time to next reference is the longest. It's basically impossible to implement. It's just used as a standard for the other algorithms. Least recently used selects the page that has not been referenced for the longest time. And principle of locality suggests that page is least likely to be referenced in the future. First in, first out. The page in memory longest is replaced. It treats page frames like a circular buffer. So Intel Optane, what does it do? Their motto is get the speed, keep the capacity. And Intel Optane was released in 2017. It's actually a brand new class of memory. It's basically a high capacity storage that can be sped up. It basically allows for high capacity storage to be sped up while maintaining affordability since it's still cheaper than an SSD. And this allows people with older systems to upgrade easily with only the addition of a single piece of hardware. And it also accelerates the system intelligently. It optimizes the computer responsiveness from system boot to application launch through learning computer habits. Now, the details on that aren't exactly known since Intel hasn't released how they do it, but it sounds like they're using some sort of artificial intelligence and machine learning to learn your habits. Performance statistics. So overall system performance is up to 28% faster compared to regular hard disk drives. And it increases system performance for hard drive access by up to 14 times faster. And it also improves everyday task responsiveness by 2 times. And what this means is faster response times equals more work done in less time. And also it has faster response times than SSDs currently on the market, which is very, very interesting, which is why I was so fascinated by this technology. And so how it works, you might be wondering how it works. It uses something known as 3D crosspoint technology, which works to store information without transistors and is a lot more dense and therefore can hold more information. But unfortunately, the exact details on this are not known since Intel is keeping it under wraps. Overall, Intel Optane creates a cache bridge between DRAM and storage and acts like an intelligent cache of some sort. It also has a system accelerator software that learns your computing behaviors and adjusts to make everything you do faster and easier, like virtual memory. To me, it seems like a pre-paging process since it has software that learns when something is going to be needed before it's going to be used. But there are not too many technical details available for competition purposes. Something like Intel Optane and its future has a lot of potential. For example, it might even be able to achieve optimal policy with its virtual memory, or get something very close, something closer than we've ever been before. So that's really exciting. It also will make computers faster. The current Optane technology will make your traditional hard drive just as fast, if not faster, than a NAND flash SSD. It also will offer better cloud computing, which is really beneficial to all of us since we are all on the cloud. And the Intel is currently offering an Optane SSD for enterprise customers, but eventually, as Moore's law states, those prices will go down and it will be available to more of us, and overall computing will improve towards Optane. Best of both worlds. Optane SSDs are less volatile, meaning they can store things even when powered off. So when you shut off your computer, RAM gets rid of all of your temporary storage there, but Intel Optane can store things a little longer, for like a couple days longer than RAM. And therefore they can be used as storage and RAM depending on what is necessary. Optane SSDs. As it becomes more affordable and available to everyone, Intel Optane seems like the next step in storage and memory. I really look forward to seeing its impact on computing and software development. Thanks for listening.